Okay, hi everyone. I am Gabriele Tempesta, and I will, before talking about the main topic of today, which is eco-design, I want to give a quick introduction about myself, which might maybe resonate with some of you. And so I have a bit of a messy career as a designer, and so the way I like to introduce myself usually is like this. I'm basically a former industrial designer from Politecnico di Milano with an existential crisis. And the crisis started when I was still a student at Politecnico di Milano in 2007, and I realized that designing products, industrial products, it's a beautiful activity. You make people's life, everyday life better, but the problem is that in order to sustain that type of production, which is basically mass production, there is a much uglier reality to the beauty of design, which is mass extraction of resources so that you can sustain the production, and then mass pollution as a result of the production processes, and also mass exploitation so that you can basically get cheap labor to keep the prices of these products lower. And of course, at the end of all of this, you also have mass dumping. So as you know, most of the stuff that we design and produce, it doesn't really last very long. So this got me to think, is there a better way to design things? And I started looking for answers when I was still a student. So I started learning about how to design sustainable products, sustainable business model. And then during my master degree, I learned other aspects about design, like designing sustainable behavior, human-centered design, etc., etc. So this was when I was a student, and then I ended up working in China for about 10 years. And I worked as a design consultant for a company, for a design studio in Shanghai. And so, and then for other design studios. So I developed a bit of a mixed design experience, so from furniture to service design and many other stuff. But in every project, I did try as much as possible to apply what I learned about design for sustainability over the years. And then, of course, whenever I couldn't get a project about that had some relation with sustainability, I tried to share a little bit of my knowledge. So after 10 years of doing this type of sustainability research and trying to put sustainability into design, I decided to come back to Italy. So it's a circular journey in a way. So I came back to Italy, and I came back actually to Politecnico di Milano, which in a place called Lens Lab Polimi, which is a research group, basically one of the earliest research groups in Italy focusing on design for sustainability. And I will tell you a little bit more about that later. Now, let's talk about the topic of today. So eco-design, how to do it, how to prepare for the ESPR regulation. So before that, I want to make a quiz. Who wants to be a sustainability? So I want to ask you for 500,000 carbon credits, let's say. I want to ask you this simple question. By how much should industrialized countries reduce resource consumption by 2050 to achieve a sustainable development? So there are a few options, by 50%, by 70%, by 90%, or we're all going to be destroyed by AI by 2050. So we can just raise hands. So how many people choose A? It's a small number, but if you think it's A, raise your hand. Okay, nobody. How many people choose B? Nobody. C? One person. D, I suppose, okay, so we will be destroyed. All right, very, very optimistic. It's a very optimistic crowd. Anyway, I would also probably choose D, but anyway, the answer is this. By 90%. So this is a study that was done in the 90s. It's called the Factor 10 study, but it has been updated over the years, and they confirmed that indeed, if we want to achieve a true sustainable development, industrialized countries have to reduce drastically the amount of resources that they use. And so what is Europe doing about this? They released in 2020 the Circular Economy Action Plan. And this is a very interesting document, and it's very important for designers because it says, first of all, it talks about designing sustainable products, and it says that up to 80% of the environmental impact of products is determined at the design phase. So this means that designers have an important role to reduce the environmental impact of products. And the other thing they say is that at the moment, back then, there was not a specific law or regulation to push for sustainable design of products. So what happened is that in 2024, the European Commission released another regulation called the ESPR, which is Ecodesign for Sustainable Products Regulation. And this is a very interesting regulation because it basically says that it extends the range of products that need to be designed in a sustainable way. Because before this regulation, Europe had some rules related to energy efficiency or energy consuming products. So it was mostly limited to products that consumed energy. But with this regulation, not only we still have the energy consuming products, but we have a priority list of products that need to be designed in a more sustainable way. And for example, in the first 3 positions, we have textile and footwear, followed by furniture and tires. And then other categories of products to continue with. So as you can see, this is a bigger range compared to the original eco-design legislation. Another thing about the ESPR regulation is that it introduces specific requirements for eco-design. And like I said before, originally we talked a lot about energy efficiency, but actually now there is a broader range. So we still talk about energy efficiency, but now they also mention water efficiency, resource use efficiency. And then, for instance, they talk about toxicity, so substances of concern, basically toxic substances, recycled content, and then a number of requirements related to the life of the product. Can it be reused? Can it be repaired? Can it be upgraded? And so on. And then other requirements related to the end of life. So can it be recycled? Can it be remanufactured? How much waste material does it produce? And then there is environmental footprint, which I will explain a little later. So the thing is, these requirements that I just mentioned are general requirements, so generic requirements. It's the framework of requirements. What is going to happen, what is happening right now is that they are adapting those generic requirements for specific product categories. So for instance, for furniture, these are not yet become a law, but these are examples. But for furniture, they are thinking about specific requirements like minimum amount of recycled materials for furniture, or for instance, the availability of spare parts. So they are still discussing, but what I want to say here is that in the next few years, if you are a designer of furniture or textile, footwear, or any other category, there will be very specific eco-design requirements that you will have to follow. So you have to follow these developments very carefully. Then the SPR also says a few more things. Maybe you might have heard of this digital product passport, because it's all the rage right now. It's basically a digital repository of information about your product. So all the pieces of furniture or other products that you are going to release into the market, they will have this digital, probably it's going to be a QR code. We don't know that yet, but it's going to be a place where you can see all the information about their environmental impact, how to repair it, how to care for it. So it will have all the information related to environmental requirements. And then also there is, you need to start thinking about the substances that are not only toxic, but substances that will complicate the recycling process. Because indeed, certain additives or certain additional things you put into your material or into your product, they might create problems during the recycling phase. So they might contaminate the material. And so now you have to be careful about those, while before nobody cared about it. Okay, let's just move on. About timeline, this is an old timeline, so it has probably been updated. But what you need to remember is just this, that by 2027, 2028, the first eco-design requirements will start to apply in order of categories. So the first victim will be the textile products, and then the next victim will be the furniture. So if you are working on furniture, you may need to start working, because like 2028, 2029, which is really tomorrow, 4 years is really nothing. So let's talk about eco-design now. We finished the part about the regulation. Let's see what exactly is eco-design. So the first problem with eco-design is that there are many different definitions and there is a lot of terminology associated to that. In fact, there is a paper, it's quite interesting, it maps a lot of different terms that are related to eco-design, and so understandably it's very confusing, but there are so many words and they have maybe different meaning. My suggestion, I'm a PhD, but I used to be a consultant, as you know, so as a consultant I would say forget about the other terminology, just remember life cycle design. So, and I'll explain why. So eco-design can be considered, can be called an approach, a way of designing with a single objective. The objective is to reduce the environmental impact of your product. It's that simple, across every phase of the life cycle, or keeping into account the life cycle of the product. That's why life cycle design, or LCD, is a good terminology, because it reminds you that you need, when you are designing your product, you need to think about the life cycle design. So just remember this meme. Eco-design, life cycle design, they're the same picture. It's the same stuff, pretty much. So now a question, but anyway, it's not a big audience, but are you familiar with the life cycle of a product? Do I need to explain it, or can we just skip it to the next section? Like, how many people on the red pill that needs a refresher on the life cycle of a product? Everybody's familiar with what's the life cycle of a product. All right. Fair enough, then we can save some time, then we can skip to the next section, but anyway, there it is. So life cycle of a product essentially is 5 stages. You have to get the raw materials, that's the so-called pre-production. You need to produce your product, then you need to distribute it. Then there is the use phase, and then the disposal, which can take many possible forms. It can be landfill, can be incinerated, it can be reused, go back to the original user or to other users, or it can be remanufactured. So the important thing to know about the life cycle is that, besides the phases, is that in order to run this life cycle, in order to run all of these activities, you will need inputs, you will need materials and energy, very simply, to run the factories, the material that you need to create your products, the oil that you put into the car that drives your product, the trucks that are driving it to the consumer. So these are all inputs. And then, of course, in every phase of the life cycle, there are some outputs. There is something that comes out of these processes. So it can be, not every output is negative, it's not always pollution. For example, maybe in a factory there is some steam that is produced, that's not necessarily a toxic output, but factories also produce toxic outputs. Or the truck that carries your product, it will release CO2 and other particulate matter. So every phase in the life cycle of a product, because of these inputs and these inputs and outputs, they have effects on the environment. They damage the environment, or they influence the environment in a certain way. And normally the effect that we are mostly worried about is climate change, for obvious reasons, and that's the one that we are very constantly measuring. But our suggestion is to not just focus purely on climate change, because climate change is just one effect on the environment. So, for example, we are still dealing, even though now the problem is mostly solved, but we are still dealing with ozone layer depletion, particulate matter. I mean, we're in Milan, that's basically where the worst air in Europe, and we can go on. So we have a number of effects on aquatic environments, like eutrophication, acidification. And then what about the exhaustion of resources? So in order to produce stuff, you need to take stuff from the ground. Some resources are renewable, some are not. So that is also an impact that we need to consider, not to mention toxicity. So these 16 impacts that you see here are part of a European framework for evaluating the impact, which is called the environmental footprint. You see, it came back. So the environmental footprint is a way to measure the environmental impact, and it considers 16 impact categories. And this is actually still ongoing. For instance, some of you know about microplastics. Microplastics are not here, not because they don't exist, but because they haven't figured out a reliable way to measure that impact. In the future, we will probably have more indicators of environmental damage. To date, this is quite comprehensive. So, first key takeaway, when we talk about the so-called environmental impact of a product, we are not just talking about carbon or carbon footprint. The environmental impact of a product is actually the sum of all of these impacts and more, potentially, generated across the life cycle of the product. So this is the first thing to know. And then the good thing is that we found a way to measure these impacts, as I mentioned before. And so we are actually able to say now, with a process called life cycle assessment, or LCA, we are able to say for each phase of the life cycle how much our product is damaging the environment. So if you use the environmental footprint method, it's a very good method because it can compress all of these impacts into a single score with different weights. And so, for example, if you look at this graph, which is a totally invented graph for whatever product, what do we see here? We see that for this hypothetical product, we have a very large impact in pre-production, so to basically produce the materials to make this product. This impact, we see that a big contribution is given by climate change and then other impacts. But it doesn't really matter. What matters to you as a designer is that which life cycle phase has the biggest impact. We don't particularly care whether it's caused by climate change or other things, because there's not much you can do about it. So essentially, the LCA tells you how much your product is damaging the environment. You can do it with a number of software. OpenLCA, it's a free-ish software because you can, there are some free databases, even though they are not always updated. The one that we use in Politecnico di Milano is Cima Pro. In any case, LCA is no joke. It's a complex process. It's a bit expensive. It takes a while to make, but from a scientific perspective, is the best starting point for a reliable eco-design process, because if you need to lower the impact of a product, you need to first know what is that impact. You need to measure it in some way. And so the LCA gives you the first critical information. How much is the impact of my product across every phase of the life cycle? Now, another question, another small quiz. This is a bit harder. So if we consider for, okay, let me rephrase. So which one among the following products has the lowest environmental impact? So, you know, when you go to the toilet, you wash your hands and you want to dry your hands. So there are some paper towels using virgin paper. Then we have the hand dryer, the classic hand dryer, you know, with the heating element. Then we have paper towels by using recycled paper. Or we have a high pressure hand dryer, kind of like Dyson style. So it just uses very high pressure air, but no heat. So I want to ask you which one you think among these four has the lowest environmental impact. So let's do it like before. How many people with vote A? Nobody. How many people vote for B? One person. All right. How many people C? Nobody. How many people C? Nobody. All right. And then how many people D? Okay, okay, so basically, all right, fair enough, that's clever. Very good. Because most people tend to indeed go for the recycled paper. But actually, what is interesting is to know why we have this answer. So to do that, we need to look at the life cycle assessment of this product. So this study was commissioned by the company that produced the high pressure hand dryer, the accelerator. So what they did was measuring the impact of these four different products across the 5 stages of the life cycle. But they did one mistake, well, not a mistake, but it's something that at least we don't recommend as academics. They only measure the climate change. So they basically didn't care about any other environmental impact. They just checked how much impact on climate change does each of these products have, which is a partial vision. I mean, it's only one of the impacts, but we will forgive them for this. So let's see for the regular paper towels, the one we're using virgin paper. So for the virgin paper ones, we see that the biggest impact is in the manufacturing phase, because indeed it seems that manufacturing paper, turning basically wood into usable paper, in terms of climate change impact, has a very large effect on the environment. The conventional hand dryer, by comparison, has a massive impact in the use phase because it's an energy-consuming product. You need hot air to pump it constantly to dry the hands. The recycled ones, interestingly, they have more or less the same impact for the manufacturing, but they have a lower impact in pre-production to produce the paper because it's recycled. You are taking it from waste paper. And of course, recycling doesn't mean recycling has no impact. Recycling does have an impact. You still need to collect that paper, you need to drive it to the places. So, but the impact overall is less than cutting down new trees. And for this one, doesn't really take hard to predict. What did they do? They removed the heating element. They also made sure that the moment you remove the hands, the thing stops as a very quick cool down timer. And so, of course, the impact is less. But then you might ask, how can you even compare these four products? Because these two, they have electronics, they have plastic, they have metal. This one is basically paper and a plastic enclosure. How can you even compare this? And that's a good question. So I'm teaching you now a critical concept that is not very often talked about, which is the functional unit, which is very important when you talk about life cycle design and life cycle assessment. What is the functional unit? Basically, it's a way to quantify the performance of a product. And this is basically your benchmark to carry out the life cycle assessment. So what did they do? It's very simple. They took this product, which was the reference product because they are the producer of this product, and they checked, okay, how long does this thing last? It lasts, I remember, around, I think, 10 years. So what's the function of this thing? Is to dry hands. So they said, okay, how many hands can I dry with this product in 10 years? And they counted, and they made an estimation of 260,000 pairs of hands. This is what the amount of hands that can be dried by this product in 10 years. So the functional unit is defined as this, and we can easily compare these products now that we have the functional unit. So, for example, for this product, in order to satisfy this functional unit, what do we need? We need one hand dryer, because one is sufficient to dry 260,000 pairs of hands. And we need the total electricity that we will use to dry those hands. So that's actually a lot. 1,380 kilowatt hours is no joke. For this one, the same, you need just one. I don't know here if they also include the repairs or replacements. It seems not if I look at these results, probably not. But in any case, so you need one product and then the cumulative electricity, and that's around 5,000 watts. So what happens for the other two? You need one dispenser, but then you need the paper. You need a lot of paper to dry 260,000 pairs of hands. So they made an estimate, and to dry that amount of hands, it's basically, let me give you just a figure. With 38,000 square meters of paper, that's enough to plaster 5 football fields. And that is why we get these results. Because indeed, if you compare the impact of producing all of this paper per functional unit, it's better to use a high pressure hand dryer. And that's why the impact is lower. With regards to climate change only, perhaps the results might be different if we include all of the categories, but that's not something that we have data at the moment. So the main takeaway here is that setting the correct functional unit when you are doing life cycle design and life cycle assessment is very important, because then you can basically compare your product with competitor product as long as they have the same function. So when we talk about materials, there is a lot of talk about sustainable materials. It's not a good question to ask which material is more sustainable in a generic way, because it doesn't mean anything. The better question is which design choice can deliver the same functional unit with a lower impact. So choosing a material is also a design choice, but you need to always relate to the functional unit. If I make this couch with cardboard, maybe it's not going to last as long as the original if I do it with these materials. Maybe I'm going to need so many replacement couch that in the end the cardboard, which is supposedly a sustainable material because it's recycled, maybe the cardboard couch is going to have a bigger impact than this one, because this one lasts 10 years, everybody can sit on it, and the cardboard couch, after a year, you have to throw it away. So that's why it's always good to think in terms of functional unit. So the fundamental question, how do I reduce the impact? After I've done my LCA, I've seen my results, how the hell do I reduce the impact? And here, there is a lot of confusion. So there are many strategies or many ways to reduce the impact. You might be familiar with this one, which is the 10R of the circular economy, which is, I mean, it's a legitimate framework. The problem with the 10R is that it's a little bit reductive and it's a little bit dogmatic, because it basically always says is like, okay, if I'm refusing, whatever that means, rethink, reduce, I'm doing good. So I should always go for this, and then the other stuff have a lower priority. But in reality, it's not so automatic. It's too dogmatic, because in some products, maybe it may not be the case. And in any case, this is one. If you search for circular strategies, many different frameworks, many different approaches. If you search for lifecycle design strategies, there is a little bit less approaches, and because this lifecycle design was there way longer, way before circular economy. Lifecycle design was something from the 90s. Circular economy, it's something that arrived in the 2010s, even though it's basically related. So there are many frameworks. At this point, you can either do your studies, try to find the synthesis, or we can just use the framework developed by Politecnico di Milano and pretend nothing else exists. And that's exactly what we're gonna do here, because I'm from Politecnico and I can vouch that these are good approaches. And I will introduce the framework that we use by comparing it with the circular economy. So this you must have all seen it, the butterfly diagram. So this is the circular economy, how it works. So it's about circulating materials, right? So in the framework that we developed at LensLab, one of the strategies is to optimize the lifespan of the product. So this basically includes reusing the product, remanufacturing, maintaining, upgrading it, etc. So it's all in there. Then you can extend the lifespan of the material. So make sure that the material survives after your product is disposed. And so this relates to recycle from the circular economy. Then we have facilitate disassembly, which is a bit of it's a supporting strategy. You can use this strategy either to extend the material lifespan or to optimize the product lifespan. It depends. You can make something easy to disassemble because you know you will be recycled, or maybe because you want to facilitate reuse, repair, upgrading, or maybe both. And then we have the biocycles, so basically making sure that biological materials return in the nature with the minimum damage. This is what we do with the optimized renewability and biocompatibility. We will talk a bit more in depth about this later. So these already cover all of the stuff that the circular economy tells us. And of course, some people also remember when talking about circularity that reduction is also important. So it's not just about circulating things. You also need to reduce the flow of material that is circulated. So of course, we need to minimize the consumption of material. But what about energy efficiency? We talk about circularity, we talk about materials keeping going, but what about the energy consumption? What about electronics? You need to minimize also the energy consumption. This is something not very obvious when we talk about circularity. What about toxicity? Toxicity is not something explicitly mentioned when we talk about the circular economy, but we need to focus on toxicity as well. So we have minimizing toxicity and harmfulness. So here the point is not to say who's good, who's not good. The problem is to understand the difference between sustainability and circularity, because they are not the same thing. They are not a synonym. Lifecycle design strategies are focused on environmental sustainability, which is very broad. It includes toxicity, it includes energy efficiency, etc. Circularity is a subset of sustainability, but it doesn't necessarily mean that if a product is circular, it's sustainable. It depends. So that's why we recommend to follow this. With this, you're good with circularity and you're good with the ESPR. So now let's see some actual examples of this life cycle design or eco-design strategies. For the first one, minimize material consumption. Very easy to understand, very no nonsense. It means you make the same product, the same functional unit, but you use less material. Many ways to do it: make the product lighter, reduce the packaging, etc. So I'm not going to go through all of this because we don't have time, and we also started very late. Let's see some examples. And before the example, also keep in mind that by applying this strategy, you are working on these requirements from the ESPR. So I like to quote this movie that I think most Italians know, because this is actually an interesting product. That it's very iconic, the Sacco armchair. So it's an interesting product from a perspective of material reduction, because what did they do here? They basically made sack of plastic beads, which only weighs less than 4 kilos, but still, with just this weight and this mass and this design, it's able to be a comfortable couch, unless you are Fracchia or Fantozzi. But for normal people, it's actually quite comfortable. And so it's much easier to produce because you don't need to have the frame, the wooden thing, the springs, and all the other stuff. So it's a good example of minimizing the material content of the product. And this became, I mean, this is like a design icon, and it has won also the Compasso d'Oro. And so it's an example that innovation can also be sustainable. And of course, probably they didn't design it with sustainability in mind, but as it turns out, this is actually a clever idea from an eco-design perspective, and it's a killer product. Or, for example, this chair by Herman Miller, they instead of making it very material intensive, they basically created this type of rib. They call it a kinematic spine that allows it to be very comfortable and adapt to the to the movement of the body, but they reduce the material consumption to do it. So because they basically dematerialize the chair, and it has become quite a popular multi-purpose chair. It was launched in 2009. They're still selling it. It's one of their best-selling multi-purpose office chairs. Let's talk about energy consumption. So this one also, not much to say, make the product more energy efficient. That's a no-brainer. But not only that. So about energy efficiency, many examples, but if you go, for example, with Hans Grohe, they made it really a priority. So they created a technology that reduces the amount of water that comes out, but still providing a comfortable washing experience. And of course, if you have less hot water, then also you're going to consume less electricity. This might be good to have, especially now, given what's going on in the world. And so this is an example of selecting the most energy efficient consumption system in the use phase of the product. And they rolled out this thing in 27, and now it's basically been rolled out into almost all of the products from Hans Grohe. Their plan is to roll it out into 100% of the product line. And then there is this one, another iconic product from the 70s by Gaetano Pesce. The thing is, originally this design was designed to be shipped flat. So it was completely vacuum packed, and the moment you unopen it, magically the couch would come to life. And so this is also an example of reducing the energy consumption, in the sense that when we talk about energy, we're not talking only about the electricity used by your product, but we're also talking about the energy to transport your product. That is also an energy consumption. So this is an example of minimizing energy consumption in the transportation and storage phase, because with this, I can transport thousands of these couches with one truck. If this thing was bigger and it was not vacuum packed, maybe I can transport maybe 10, 100. So this also counts. Problem is, it's no longer like this. They discontinued this because the gas that they used to expand the thing it was the Freon gas. It's a CFC gas, so of course that's not good. The new version looks like this. It's already expanded. So basically it's no longer sustainable because it's a massive piece of material. And so this one, in principle, if they did it with a non-CFC gas, with maybe a more sustainable gas, let's say, it doesn't have much impact, then it would still be a good example. But anyway, it was an interesting story, nevertheless. Minimize toxicity. Also, this one, very simple, selecting materials that are not toxic or energy sources that are not toxic. There is a company called Ecobalanza in the US. They started doing these couches that were not unallergic couch, because the founder, she had a son that suffered from allergy, and every time he would use the couch, he would not feel well. And so she made it her mission to create a couch that is non-toxic and allergy-free. And so what did they do? Well, basically they choose, for example, organic cotton, wool, natural latex. They don't use flame retardants, etc. And it has been established in 27. The website is still there. They're making good business because it's a niche product. It's a niche product that it's actually selling pretty well, because it appears there is a lot of people with allergy issues, and so that's something that is a good fit for them. So optimizing renewability and biocompatibility. So this means you design your product so that it uses renewable resources, and so you're able to conserve resources for future generations, because if your resource is renewable, then you are not depleting it. And biocompatibility relates to the fact that the materials that are used in your product are able to be reabsorbed by the nature without causing damage. And if damage is caused to nature, then we are damaging the ability of the planet to produce new resources. So classic example, it's about bio-based plastics, for instance. This is a company, Italian company called Krillmat, which makes bioplastic using also some waste products from food industry. And they turn this into, they provide the material, and then some designers have created some quite interesting design with their product. And this has been pretty successful, because they basically won an ADI Index award in 2025. They got a lot of money recently, and they set up a factory in the outskirts of Milan. So this is a successful example of a company producing a bio-based material. So this is an example of this strategy, because by using bioplastic, you are not exhausting fossil resources. You are using biologically based plastic from starch and other plants, plus the waste from the food industry. Then we have optimizing product lifespan. There are so many ways to do it. You can improve the ability of the user to upgrade it, maintain it, repair, reuse it, etc. Many possible ways. And with this, you hit the jackpot. You can basically meet most of the requirements from the ESPR regulation. One example of many is this high chair for kids called the Trip Trap by Stocke, which is designed to be, basically, it's like a chair for life. So by adjusting the configuration, you can transform it from a high chair into a smaller chair, potentially into a chair to be used in the adult times. And so it's an example of facilitating the upgrading and the adaptability of your product. And it's a very successful product. It was launched in the 70s. It's still on sale, 15 million units by 2023, and also shamelessly copied. So I saw this from some other websites, and even an Italian company, for Papedretti, they invented the evolutionary chair, but I mean, it's the same thing pretty much. Maybe cooler with the triangle, or probably cooler because we're Italians, we're Italian style, but still is basically the same design. Anyhow, almost finished. Extend the lifespan of materials. This relates basically to giving value to the materials after the product is disposed. So it's about recycling, facilitating recycling, or composting, if applicable, or combustion. And there are many possible ways, but for example, this is an interesting product called the Spoke Sofa, where the designer specifically designed it to facilitate recycling. So what did they do? They designed it so that the material assemblies used only three single material components. So you have all the stuff made of one type of wood, you have this stuff with the recyclable cover, the upholstered part with the recyclable cover, and then polyurethane foam. So it's basically 3 or 4 materials, very easy to separate, because of course, when you recycle stuff, if it's difficult to separate different materials, recycling is really difficult. And so if you facilitate the separation, then you also facilitate the recycling. And also they used very few materials. In fact, this product got an eco label. Eco label, it's a big deal. It's not easy to get an eco label, the European eco label. And they got quite successful and ranked into Design. So it's an interesting company and a very, very clever and very elegant design. And then to finish, facilitate disassembly. So how to make disassembly easier for either to facilitate the recycling of the product or to facilitate to optimize the lifespan. Many possible ways to do it. Let me give you just one example. This is a company that makes floor tiles. It's called Interface. So they developed a special type of adhesive, which is this one, which is a small square of adhesive that is like double-sided. You put it on the ground, you can install your tiles. It's very resistant, but then when it's time to remove some tiles, maybe they are dirty and you want to remove them, or maybe, I don't know, the office gets smaller, for some reason AI has replaced all the people, I don't know, and the company will come back and take back their tiles. And it's easy to do it because instead of plastering the ground with glue, they just use this tiny, small adhesive, and then they can easily recover their materials in order to recycle it. So in this case, they use a permanent joining system that can be easily opened. And they have been running a very successful recycling program where you call them, they come, they take back the stuff, and then they recycle it. Since 1995, they started doing this. So this is the whole framework. Sorry, I went a bit fast, but we started late and there was a lot of content. But basically, these are the life cycle design strategies that have been developed by Lens Lab Polimi and that we humbly recommend to give a look. I want to close with a couple more things. So these strategies, of course, you look at them like this, it feels like that they are all on the same space, but in reality, you have to choose, you have to prioritize. How do you even choose where to start? So let me give you another small quiz, but this time less fancy than the other one. So this is a life cycle of a product with the 5 stages. Now, let's say that my product is this thing, whatever it is, this type of joint. Let's say that I only apply one strategy, minimizing the material consumption. I apply this strategy to the maximum possible level. I dematerialize this product as much as possible. And it becomes, for example, something like this. So, in your opinion, if I apply only this strategy, in which phases of the life cycle did I reduce the impact? If I basically just apply minimizing material consumption, and so basically the final result is something like this. So, where did I reduce the impact? In which phases of the life cycle, do you think? Anybody wants to answer freely? Yes. Any other phase? Where else? Sorry? Production. Where else? I'll take one more answer. Where else did I reduce the impact? Disposal, correct. And also distribution. So I reduce it in pre-production. Why? Because I'm using less material to produce the product, obvious. Production also because I'm basically running through the machinery less material, because this product requires less material to be produced and so also to be manufactured. The product is lighter, so I have a lower impact in distribution, and also I have to dispose less material. So if I apply minimize material consumption to the maximum possible limit, theoretically I can reduce the impact in these phases of the life cycle. So the same logic applies to the other strategies. So each strategy can reduce the impact in specific life cycle phases. To explain this, it would take another 4 hours, so I can't explain you this, but just know that with this framework, you can map exactly where in the life cycle you can reduce the impact. And that's why it's quite a useful framework, because it tells you exactly where you can have improvements. So to prioritize which strategies to use, you need to find a way to calculate how much impact you can theoretically reduce by applying each strategy. And also, of course, you need to consider how much you can realistically improve your product, because, of course, if your product is already very much dematerialized, maybe you can't further dematerialize it. Maybe you have to use other strategies. So, that said, this is basically it. What can you do right now about eco-design? So if you are a company, of course, take a look. If you didn't do it already, now it's a good time to look at it at the ESPR regulation, and also follow the latest releases by the GRC about which requirements you are lagging behind. Also, it's a good practice if you have enough funds to commission a life cycle assessment of your product, so that you can actually see how much is the impact, and that data of the life cycle assessment can already be used to prepare for the digital product passport, because then you can basically already have the data to show on your digital product passport about how much is the impact of your product. So you got your work done before this thing is even released. And you can use this LCA also to begin redesigning your product. And of course, get help from designers to redesign your product according to Ecodesign. And if you're a designer, study this stuff and then try to work for companies who need you more than ever. Now, of course, basically the vision of Lens Lab is to provide education on design for sustainability, and we provide everything open access, so everything is 100% free. So if you go to this website, lenslab.polimi.it, if you go to learning resources, we have courses that are uploaded on YouTube, and we upgrade them every year, lectures, guidelines and cases, tools, and it's all 100% free. So just go to these websites and download and study whatever you want. Of course, if you study all of the stuff on the Lens Lab website, you will be an expert, but if you need help right now, you may just, if you want, you can also hire us to help you if you are a company. So Lens Lab, essentially, we work with the university we are at the university, we teach eco-design, we've been teaching eco-design for many years, but of course, we also do consulting. So we've been one of the first in Italy to introduce product design for sustainability and system design for sustainability. We're talking about the late 90s. And we have worked with a number of companies over the years to help them design more sustainable products in many different ways. So it can be doing a life cycle assessment. It could be, for example, doing some guidelines for their designers and engineers, product specific. So we work, for example, for this company, this is Necta, they do vending machine. They came to us and they asked us, we want to design sustainable vending machines, but we don't know how. So we did the life cycle assessment, we identified which strategies were the most relevant ones, the most effective ones to reduce the impact, and then we created very specific guidelines, design guidelines that their designers could use to make these products more sustainable. We can also take it a step further and create tools for eco-design. So for instance, this is something we did for DeLonghi, where we did the LCA and the handbook of guidelines, and we translated that handbook into a tool that their designers can use, for example, to check how much they followed the different life cycle design strategies, and then they can orient the design process. So you have a basic idea of how much did you do minimize material consumption, how much did you minimize the energy consumption, and so on. And so it's a good tool to use before doing an LCA. It helps you see how well you apply the life cycle design strategies. Then also we work with companies like Artemide to help them develop ideas for new products. So we actually did co-design products together with them. Then we also develop some scenario, if you're interested in going beyond eco-design and designing a sustainable business model, a so-called circular business model or product as a service, this is also something that we can support people with. And of course, lectures, training, and other things. Now, that said, I finished. I don't know how long I took, but probably way more than, well, not so bad, actually. I finished on time. So if you want, you can add me on LinkedIn. We can talk there, but since we still have time, they told me I can go on until 8 o'clock. Probably I won't, but in any case, any questions, any comments, anything you would like to, anything that was not clear? I went a bit fast. So yeah, the mic is yours. Yes. Yes.
Do you think that AI, for example, could help getting to the goal?
Yes. Yes, I think AI can be good at the beginning. You could give it a product, and even without a life cycle assessment, maybe you should probably give it also some knowledge about these strategies. Otherwise, it will pick random things without understanding it. But you could give it, let's say, either the book that we wrote about these strategies or maybe a summary of something. And then it should be able to give you a hint. The problem is that, like most things spit out by AI, if you don't have enough expertise, you are not really able to tell if those strategies are the best ones to go. So at the end of the day, it's still better to do a life cycle assessment. But if you want to do a qualitative evaluation, purely based on AI and a little bit of common sense, I think it's a good starting point. Actually, one of the tools that we provide for free open access, it's basically the first section of that tool. It has a qualitative evaluation. So we said that the strategies need to be prioritized. If you have an LCA, you can literally use numbers to assign that priority. But if you don't have the LCA, you can do it qualitatively. And so in that tool, you can choose for each strategy if it's high, medium, low priority, or no priority even. For that one, there are some checklists you can answer. You could easily give the checklist to the AI and say, okay, I've got this product. How would you answer the checklist? At least it can help you to think maybe of some. So in that sense, I think it's good, but it's a qualitative thing with its own limitations. But definitely can save you some time as long as you don't overly trust it. Any more questions? Yes. Don't worry. Yes. Is the opposite. Yes. I understand. Yes. No worries, no worries. That's. I'm happy to have one more person attending the lecture at least. Better train them young. So, luxury. So no, indeed, actually, if I think about even, for example, my parents, they have some clothes that they bought for quite a high price back then. They are still in perfect condition. So I think it's also a problem. It's a bit of a cultural issue. No, it's mostly a cultural issue. And so we need to recreate this habit or this mindset that is better to invest in quality. But of course, it's a bit complex, especially given the economic time, the fact that the middle class purchasing power is also reduced. I would say the only answer to that would be that we need to continue educating our clients, whether it's regular consumers, but also clients, for example, architects, so people who commission buildings, architectural projects. All we can do is to try to educate them. One way to convince people sometimes, at least in the professional world, is with examples to say, okay, this company did it, these other companies did it, or you play with the numbers. You basically tell them that there are benefits, there are going to be lower costs, you're going to spend less into maybe redoing things, etc. But sometimes it may not necessarily be about using really super durable materials. Maybe you could also say, I invest a little bit less in the durable materials, but maybe I design the way my building is made so that it can be easily upgraded, adapted, maintained, retrofitted. So it can be, maybe it doesn't have to be everything, bomb-proof. So it's always a complex thing, but client education is a must. But first you need to be aware of how this stuff works properly, and then you can properly educate the clients. But indeed, the challenge is open. Yes. IKEA, yeah, you open. Yes. Exactly. No, exactly. IKEA, I mean, you smashed an open door. IKEA, there is an interesting documentary on Art TV. I think it's a channel. They have documentary about IKEA, and there is an interview of the founder in the 70s, and the founder very candidly says, we used to inherit furniture from our parents, our grandparents, and stuff lasted 20 years, and it's something that you inherit. And then he says, but in fashion, you buy a suit, and then every 3 years you change it, and so that's what we want to do. We want to do something like that. So he just says it very, very calmly, very openly. At the time, it was a breakthrough. Nobody realized it was complete bullshit from an environmental perspective. And so now, already for a while, IKEA is talking about sustainability, circularity, etc., but their business model is fundamentally wrong. So they can paint it circular as much as they want. It's a problematic business model. Of course, it's true, there is democratization, even though if you inherit a furniture, then you don't even need to pay. You got it free from your grandparents. But I think still, it's IKEA can still do something about it. They could probably, if they follow some decent eco-design principles, they should probably work on toxicity, and I know that they are working on some recovery programs. I know that in some countries, I think they are experimenting furniture as a service even, which is also something that makes sense. And if you design, that's actually one part I couldn't talk because there is not enough time, but if you do products, if you design, instead of just designing a product and apply eco-design to a single product, if you focus on the business model, if you do it right, you can create an incentive for your company to design in a sustainable way. So if IKEA at some point starts to seriously launch a furniture as a service plan, where you basically pay monthly or yearly, whatever, and you get access to furniture, and maybe you want to change, and you send it back, and they own the property, so it's no longer your furniture, it's the ownership belongs to IKEA, then they will have an interest because it's their stuff, they need to take it back. So if I need to take back my stuff and it's already broken, then I need to pay money to dispose it. That would be stupid to design it as a disposable product. So if they do this business model, they should probably design it so that it can be long-lasting, they can recover as much stuff as possible, and they can maybe reuse it in another furniture. And some companies, they're doing that. There is a company doing office chairs, it's called Gispen, and they have a furniture as a service type of lease. And all of their furniture are designed with modular components, they recover a chair, maybe some parts is really badly damaged, they can't use it, but maybe they reuse some other parts, like the cushion or the legs or other things. And so they built in place the system, they designed the product and the business model. That would be the most clever way to do it, of course. It's more complex, but it can be done. Sorry, it's a long answer. Any other questions or comments, or was it stuff that you already knew, or was it all new for you guys? How about you two? Like, were you familiar with these principles or not? Please, yes. Yes. Yeah, but you mean for hardware or for Yes. Yes, but the thing is, subscription for the hardware. Subscription now, to be honest, I'm not a fan of subscription either, but for software, because there are too many software that if I have to pay a subscription for every software I use, I will be broke by the end of the month. But the thing is, most of subscription, like Netflix or other things, they're all for software or like intangible goods. What we're talking about here is subscription for a physical good, a physical product. So instead of you buying the phone, you could say maybe there is a plan where you lease your phone. Maybe, let's say, Apple could introduce a leasing plan where you get everything and you pay monthly, you get access to the phone, and then a new model comes out, you give it back to them, you don't pay anything, and you just get the new model right off the bat, for example. Of course, this subscription model, which is not only subscription, there are different variations, there is also pay-per-use, etc. There are many formulas, and actually we have a course related to that, you will find it on YouTube, about system design for sustainability, so we talk about that there. But this model is not necessarily applicable to every single product, but typically for some consumer products it might make sense. For B2C it might make sense, for B2B especially it makes sense. For very expensive equipment, having subscription can reduce the entry cost, and so people can actually afford expensive equipment much easier. So it depends. It depends also on the culture. In some countries maybe it's premature, in other countries they are already evolved in terms of mindset. But the important thing is to know that this is an option and then try to start a conversation with your clients. Or if you are about to start a business, for example, you can also consider maybe it could be a business done with a product as a service. And you can experiment before you build even the plant. There are many ways to make simulations or tests, fake websites, now with AI, fake advertisements, to just see if people are willing to, buy a subscription service for a hardware product. Any other question? At this point, you have to ask a question because everybody asked one. No, I'm not forcing you, but of course, if you have any question, is this, for example, is this a topic that was taught in Brera? Are they teaching this in this way? Like, what are they talking about in the Brera Academy? Beh, sì, di quello abbiamo parlato. Eh sì, esatto. La differenza, no, esatto, cioè non è che ci sia, siamo tutti italiani qua, immagino. We're all Italian, right? No. Vai, facciamo in inglese. No, anyway, circular economy. So what we talk about here, this is all stuff related to the circular economy, but the framework is a little bit different. So by applying eco-design, you are indeed basically focusing on the circular economy, but it's only one piece. Because with eco-design, with these guidelines, you will also follow, you will also work on energy efficiency and toxicity, which are not always mentioned when people talk about circular economy. That's why we try to at least, you know, clarify the differences. But we are all working on the same goal. We are just providing a more comprehensive framework, let's put it this way. But this is definitely circular economy related, 100%. And even more if we talk about these subscription systems, let's call it product service system or product as a service. All right, I think pretty much the time, we finished exactly in 1 hour with Q&A. So I think if there is no further questions, yeah, feel free to get in touch. Visit the Lens Lab website. Everything is free there, so just take whatever is useful. And if you need me, you can find me on LinkedIn or just search my name, and yeah, I'll be happy to answer any further questions. So thank you for coming. I appreciate it, and enjoy the rest of the design week. Okay, thank you.